One major advantage of Fusion 360's unified workspace is that you're able to create animations, renderings, CAM toolpaths, and simulate your design on the same tool that you used to design it. In this tutorial, you'll learn how to create your first simulation, interpret simulation results, and make an informed decision based upon those results. So let's get started. Let's start by opening, and then we'll save the file that we'll use in this tutorial. In this example, it's a CPU and a heatsink. With the sample file open, we'll then switch to the simulation workspace. When doing so, you'll notice, similar to the other workspaces, that the toolbar will change to reflect simulation-specific commands and options. Next, we'll create a new simulation study. Being a CPU, our biggest concern is related to dissipating the heat generated in the chip, so we'll create a thermal study. From here, we're going to go ahead and define what are typically called boundary conditions, things like loads, contact, and other details for the study. We'll start by defining the load. Using the drop-down under load, we'll select internal heat. Then from the graphics area, I can select the general CPU part and define the value at 39 watts. Next, we'll apply convection heat to the heatsink and circuit board. The convection load we're applying here is defining the heat transfer from the selections and the surrounding fluid, in this case the air. From the load drop-down, we'll select convection. Then to make selecting the faces of this heatsink easy, we'll select the Select All Faces option, then click on the heatsink. This will get all 246 faces. But there's one face that shouldn't be included in this study. That's the one that is not in contact with the air. It's the one touching the CPU. So let's adjust this section so that we'll turn off the Select All Faces options. Hide the circuit board and CPU, and then click on the bottom face. The number of faces should now reflect 245. Finally, we'll set the required values for this convective load. After adding the other convection load to the circuit board, we're ready to solve this. To solve, just click the Solve button. And after the math is run, we're able to start interpreting the results. The default results shown will give you temperature results, but thermal studies also offer heat flux information. You can filter the results depending on values. You can slice results. You can show minimum and maximum. You can probe areas of interest. At the end of the day, you should be able to gain enough information to understand whether your design will perform adequately. Now in this instance, I'm unsatisfied with the maximum temperature of my device, so let's make a design change. To make the design change, we'll just switch workspaces back to the modeling environment. And from the Modify pull-down, select Change Parameters. The parameter I want to change defines the height of the heatsink fins. We'll increase this value to 15 millimeters. With that done, let's return to our simulation workspace, where we'll find it's warning us that the mesh and the results are now out of date. To update these and get new results, all we need to do is hit Solve again. In very little time, I'll have new results to check, and I can gain insight on whether or not that design change will meet my requirements. You should now be comfortable with the basic workflow within simulation. Set up the environment, determine the operating parameters, solve, and interpret the results. Make sure to click the provided link and jump to the additional tutorials to try the other simulation types Fusion 360 has to offer.